we have discussed about um, passing arrays as parameters, and for passing arrays as parameters in C to C functions, we take recourse to call by reference. Otherwise, for all other parameter passing, we take recourse to call by value. And just to summarize the call by value and call by reference, the difference is in call by value, we copy the value of the actual parameter to the formal parameter, formal argument, and in call by reference, we do not copy the value, but we just pass on the address or the pointer and reference to the actual parameter. Okay. So, as a result what happens, that if any change to that variable is resulted in the function itself, in the case of call by value, that will not be automatically reflected to the main program, but in the case of call by reference, since there is no other separate copy, that will automatically be reflected. Just to conclude that part, we will see a number of applications of functions. Just to conclude that, let us have a quick look at one function. There is no array, but just division of the prototypes that you can see here, finding the maximum of 3 integers. So, we have the header file here include stdio.h, then here we declared a function prototype. The actual function maximum has been written later. So, here you see that what does this line tell us? This line tells us that maximum is a function and it consists of 3 integer arguments or 3 integer parameters will come. So, as if this is a function which has got 3 input doors and each door is wide enough to accommodate an integer. Okay. So, that much is told, and whatever is inside this, I am not aware of that, and at this stage I am not aware of that, and the output will also be another integer that is told by this. Then, so here the salient point to see is that here I have just it was sufficient to just specify the types, no names have been put in. Now comes the main program, that is very simple. A, B, C are 3 integers. So, they are local to this function, enter the integers A, B, C are entered here. So, you know what A is, what B is and what C is, and then you are calling inside. See here inside the printf, I can call maximum with the parameters A, B, C, and we come here. And here I have defined, here I did not name, the variables, here I have defined the names of the variables int x, int y, int z. So, this x, y, z are again property of this maximum, all right. So, x, y, z are here, and the algorithm of the logic is simple. Initially I make max to be x, if y is greater than max, then y is the max, otherwise z is the max, and then I am returning max. I am returning max means I am coming here and then that max is being printed and return 0. Now, my main function, where is my main? Main is here, main has got a type int. So, I am returning 0. So, int will, if at the end of the main function a 0 is returned, I will assume that the program has successfully completed. Okay. The reason I brought up this example is just to illustrate this case, that you need not at the prototype level, you can escape specifying the parameters. So, here is the prototype declaration, function calling and function definition, you know that. So, these are already repeated, I am not going into that. So, instead I will be talking about a new thing here, that is hash include. We have talked about hash include, we have used hash include, and we mentioned that hash include is nothing but a preprocessor statement, a preprocessor statement. How? Say hash include file name. We have seen hash include stdio.h, but it can be for that matter any file name. Hash include file name. Say for example, I can specify the full path, say /usr in a Linux environment /home rajan myfile.h. I want to include this file, I want to include this file in my, what is happening, this file in my program. All right. The content of the corresponding file will be included in the present file before compilation is done, before compilation is done, and the compiler will compile thereafter considering the content as it is. So, it is a preprocessor statement, that is I put that inside that hash include, that file is included and then the compilation is done. Okay. Now, let us look at this hash include example. Look at this program segment, which is my source program, which is known as proc.c. So, this is my source program. This source program has got hash include no stdio.h, but it has just said that in hash include myfile.h, and then the main program follows. Okay. Now, this myfile.h is nothing but another file which has got hash include stdio.h and int_x. So, when I include myfile.h, then this particular file will be included, this particular file, that is this segment, will be included here. So, consequently, what will happen is, when I say in general hash include file name.h, it includes the file name name.h from a specific directory, which is known as the include directory. When I say hash include, it takes from the include directory, and in the include directory I have kept myfile.h, and consequently, when that is included, the ultimately the thing that looks like is, it will look like this, because that hash include, I am sorry, there should not be an inverted comma here, it should be just hash include stdio.h followed by int_x. So, this whole thing has replaced myfile.h, and where was myfile.h? Myfile.h was under user usr include file name.h. So, that is how the include, I can have other files included in my program. Now, another point of critical discussion is macro definition. We have seen the macros like hash define. So, let us so that is again a preprocessor directive. We have seen that hash include is a preprocessor command, that means even before the compilation is done, that is copied there. On the other hand, you see the preprocessor directive of hash define string 1 string 2, that means string 1 should be replaced by string 2. So, how does it happen? It replaces string 1 by string 2 whenever it occurs, wherever it occurs before compilation. So, for example, hash define pi to be 3.14. So, wherever it will find this pi, it will replace that with 3.14. Okay. So, here for example, you see we have got hash include stdio.h, then we define pi to be 3.14 as the hash defined preprocessor command. Now, in my main program I have got float r 4 r is 4 and area is another variable, both are float. Now, area is pi times r, r is already initialized. So, what will happen is this will be translated to this pi will be replaced. So, the body will be float r assigned 4 and area is, so r is 4 and area will be 3.14 times r. So, even before compilation, this pi is being replaced by the value 3.14 as has been stated in the hash define command. We can also give hash define with an argument. Till now we have seen hash define pi as a constant, hash define some constant k to be 5 or whatever. Here we can also define some functions like you see hash define square x is x times x. So, wherever square x will appear, that will be replaced by x times x. Okay. So, for example, here let us look at this program again. I think you are not being able to read this. So, let me go back. Say let me have if I have declared say hash define square x is x times x, then in my program wherever I will get say p is assigned square y. So, this will be translated as p assigned y times y. Okay. So, this what should be done, that has already been told here, that square x is this. So, this will simply replace it. Okay. So, that is the purpose of hash define here. We can see that and so let us look at this example again. Main y is 5, printf value is y times y, that means this is being this is what has been generated after the square x has been here it was square x plus 3. So, that has become y times y plus 3. Now, which one is faster to execute? You can think of, if I write square x written as a macro definition, then I am pasting, as if I am pasting the body of the code inside this in the main program, replacing that. So, I do not need to call any function, I can write it as a macro definition, and as a result even before compilation I can get this look, and so this can be straightway applied without requiring to call a function. Now, if square x is written as an ordinary function, not like a macro definition. In that case, I have to call a function, and calling a function has got some overheads which I am not discussing here. So, if it be a very simple thing like this, it is better to make it a macro, so that it automatically gets pasted and it becomes faster. However, there is a word of caution. For example, if I had defined square x, now it is now when I am defining as a macro, it is I have to ensure that it is correct. Therefore, if I define square x as x times x, now how the macro definition substitution will be carried out? Let us look at this. If there be something like r assigned square of a plus square of 30, so it will be a times a plus 30 times 30, that is how it will happen. Okay. Now, what about r square of a plus b? It will be simply pasted as a plus b times a plus b. Consequently, the result will be wrong, because in the during execution b times a will be done first, and then that will be added with a and with b. So, this is not what I intended. Therefore, if I had done this, define this as like this and like this problem would not have occurred. So, unless I do that, this a plus b will not be, I need to take, if I define it like this, then it becomes this, which is the correct one. But unless I do that, it will lead to a wrong result. Okay. So, we must be very careful about it. This is wrong, and the macro definition should have been written as I have shown, square x is x times x. In that case, we would have got the correct result. Now, before moving to anything else, we will now look at some applications of what we have learned. We are now at a position where we have learnt all the fundamental tools without the sophistications that are required to write a program. Okay. So, suppose I want to solve a problem like this, that I have got 5 students in the class, and the 5 students have got 5 names, of course, and each of them have got some marks, total marks, right. Now, how do I represent that? And I want to find out which student, I want to print the name of the student who has got the highest marks. All right. Is the problem clear? Let me repeat the problem. I have got 5 students in a class, and I want to find out which student has got the highest marks, and I want to know the name of that student. Okay. How can I solve this problem? This is a simple problem. Here, what I will need is, first I will need an array of the names of the students. So, first I need an array of the names of the students. So, here 5 names will be stored. Very disproportionate array, and let me call this array to be name or names. And on this side I have got another array which holds the marks of the different students corresponding to the roll number, maybe 1, 2, 3, 4, 5. The marks are stored here. Somebody got 50, somebody got 55, somebody got 62, somebody 70, somebody 32, say. And their names are A, B, C, L, M, P, Q, X and Y. Suppose these are names, these are different names. Now, why do I need two arrays? This is the array called marks. Why do I need two arrays? First of all, the arrays should be holding same type of data. So, what is the type of data that the array names is holding? It is a array of character or character string. Now, how can I represent these names? I can represent them as an array of strings, or each of these names is what? Each of these names is a character array. Therefore, if I just look at names, names will look like a two-dimensional array. Now, what would be my algorithm? First of all, I will come to the representation later. What would be my algorithm? First of all, I will have to go to this marks array, which is simpler. It is an array of integers, assuming all integer marks are given. Then I will have to find out the maximum of this, and you can write a function to find the maximum of an array, right. So, let us try to write the function first. So, I have got an array marks, which has got 5 elements, all right. So, I can call a function max. Let us first of all think of this maximum, what will it return me? Say it will find out, say if I come to this, it will find out which one is the maximum and will return me an index, right. Oh, this is not the maximum, sorry, this one is the maximum. So, it will return me an index 0, 1, 2, 3. So, it will return me an integer. Therefore, I can start with like this, that int maximum of, I can call an array, integer array, int, suppose that is m, this, and the main function will call it with marks. And inside this, what will happen? You know, initially let me call a value int, this is a local max assigned m 0. So, I initialize a variable max with m 0. Now, for I assign some index I. So, I have to declare I also here. I assigned 1, I less than equal to 5, less than equal to 4, sorry. Less than equal to 4, I plus plus, here if m I is greater than max, then if I then max is mi, and that will go on. Now, ultimately what shall I return from this? Should I return the max? No, I am returning the value of I, because where I found the maximum. Now, so for that, now this I is changing. So, here I will also have to make, say, so let me just make this I to be 0. Let me make this I to be initially I is 0. So, I could have done away with this, and wherever I get this max, I am changing this I. Wherever I am getting this max, I can say that there is another max index, and I am making max index equals I. So, I am remembering where I found the max, and I will be returning the max index. All right. So, my maximum function in this way, what it will do is it will find out the maximum. So, it will return 3. So, the first thing is find max. Now, I have got an array names. How is that represented? The representation can be as strings, or it can be as an array of characters. If I consider this to be an array of characters, then remember that it is a 2-dimensional array. Okay. And I in that case I will take, so this 3, and I will come to this 3 this, and I will print out this particular element from that array. Okay. So, now what about these names? Let us see. Names is an array, say PQR or something. So, I can have this as an array of characters. So, PQR, ALM, whatever it is, and this part is blank. So, what is my declaration of names? Names will be, there are 5 names, 5 rows, and each row is a character. So, it is a character array, char names. Let me write it here. Char names 5 rows, and each row may have 3 columns, right, at best like this LMP, LMK, PQR, like that say. Now, I have suppose come with that maximum index was this rows. So, that is 3. Now, how do I print this PQR name here? If it is kept as a string, I could have stayed with %s format, but here how do I do with this? Here I can, I will print which row, I will print, I am not writing the entire code. Okay. Printf, which row would I print? I would print the names 3, but there are 3 characters. So, names 3 in a loop I have to print, right. So, printf, so how would the printing be done? How do I print one row of an array, a 2-dimensional array? So, here I come. So, I will print in a loop names 3 0 3 1 3 2. Okay. Actually, this is 3 should be somewhere here, it is confusing. 3 should be somewhere here, say A, B, C. So, 3 is actually this row. So, names I will be printing 3 0 3 1 3 2, and that I can print in a for loop. So, I leave it to you to try to print this in the character format. You can also try it in the string format. So, what we have done here is we have seen how the macros are replaced, and we will see further examples of functions all through in the future lectures, where we will be applying functions and arrays consequently.